Hello everyone, welcome back to my YouTube channel. This is Filipino explaining the Moivre theorem. Suppose z1 is equals to r1 in brackets cos theta1 plus I sin theta1 and z2 is equals to r2 in brackets cos theta2 plus I sin theta2. Prove z1 z2 is equals to r1 r2 in larger brackets cos in brackets theta1 plus theta2 plus I sin in brackets theta1 plus theta2. Solution. Okay, z1 z2, the product of z1 and z2, and remember z1 is represented by this and z2 by this one, so it's just the product. Z1 is equals to r1 in brackets cos theta1 plus I sin theta1, and z2 is represented by this r2 cos theta2 plus I sin theta2, as you can see. So the next step, what do? We open the brackets here and here. With there, this becomes, we multiply r1 with each term in these brackets, then we do the same for r2. With there, so we have r1 times cos theta1, that is r1 cos theta1 plus r1 I sin theta1, then r2 cos theta2, we take this, then we multiply again with this one, this r2 I sin theta2. Are we there? After that, we do what? We get the product now. We multiply this and this, this and this, this and this, this and this. Are we there? Okay. So r1 cos theta1 times r2 cos theta2, it becomes r1 r2 cos theta1 cos theta2 plus this plus r1 cos theta1 times r2 I sin theta2, it becomes r1, this r1 r2 cos theta1 I sin theta2, okay, plus r1 I sin theta1 times r2 cos theta2, it becomes r1 r2 I sin theta1 cos theta2 plus r1 I sin theta1 times r2 I sin theta2, it becomes r1 r2 I sin theta1, then I sin theta2. Okay, this can be written as r1 r2 cos theta1 cos theta2 plus r1 r2 cos theta1 I sin theta2 plus r1 r2 I sin theta1 cos theta2 plus, remember we have here I times I is I squared is equals to what? -1. So it gives us negative r1 r2 sin theta1 sin theta2 with there. So after that, you can see you have a term here, a common factor in this term, in this term, in this term, in this term, that is r1 r2. So we can factor out and say that r1 r2 in larger brackets cos theta1 cos theta2 plus r1 plus cos, you have factored this out, plus cos theta1 sin theta2 plus sin theta1 cos theta2 minus minus sine theta1 sine theta2. There's something I have omitted. You have an I here. Are we there? You have an I here. You also have an I here. I have omitted this now. Cos theta1 cos theta2 plus I, this I, cos theta1 sin theta2. I'm sorry for that. Plus sin theta1. You have an I somewhere here. You have an I, so it's I sin theta1 cos theta2. I think now we are okay with that. So after that, we do what? We separate the real parts and the imaginary parts. The real parts are those parts without an I, and the imaginary parts are those parts or those terms with an I in complex analysis. So this becomes r1, r2. These and these are like terms. These and these are like terms because this and this are having an I. Then these two doesn't have I, so they are like terms. These are also like terms. So we have cos theta1 cos theta2 minus this one now sine theta1 sine theta2 plus, you can factor this I out and say I into cos theta1 sine theta2 plus sine theta1 cos theta2. Okay, hope we are good. Okay. So this is the real part and this is the imaginary part. So we have to remember this trigonometric identity that says, can say but cos theta1 cos theta2 minus sin theta1 sin theta2 is equals to cos theta1 plus theta2. You have to remember this. So you can see that we have cos theta1 cos theta2 minus sin theta1 sin theta2. So the whole of this is equals to what? The whole of this one is equals to cos theta1 theta plus theta2. Now we can replace this or substitute this with this one. Say that r1 r2 into cos theta1 plus theta2, are we there, plus I into cos theta1 sin theta2 plus sin theta1 cos theta2. Are we there? Also, you have to remember this another trigonometric identity that says cos theta1 sin theta2 plus sin theta1 cos theta2 is equals to sin theta1 plus theta2. You can see in this working, we have cos theta1 sin theta2 plus sin theta1 cos theta2. So the whole of this one, the whole of this is equals to what? Is equals to this. As I have said, that the whole of this one is equals to what? Is equals to that one. Are we there? So we can replace this or substitute this one with this one and say that r1 r2 into cos theta1 plus theta2 plus this I sin theta1 plus theta plus theta2. So z1 z2 is equals to r1 r2 cos theta1 plus theta2 plus I sine theta1 plus theta plus theta2, and we have now proved. Remember, the question was we were to prove z1 z2 is equals to r1 r2 this one. You can see, you can compare and see, of course theta1 theta2, of course theta1 theta2, as you can see, plus that one. So thank you so much for watching. Please subscribe to my YouTube channel for watching, to support my efforts. Till next time, bye bye.